In today's lesson, graphing f of x, which equals ax squared plus c, we are going to be looking at what happens when we add a constant to a parabola. Last lesson, we learned what happens when we have a coefficient and compared to x squared. Well, now what happens when we have a coefficient and a constant? So we're going to learn how to graph ax squared plus c. We're going to learn to translate it and model and solve real world problems. What c is going to do is move up and down that y-axis. So without c, our vertex will always be 0, 0. If we have plus c, that means we're going to move it up. If we have a minus c, that means we're going to move it down. So if we take a look at our graph, it says graph g of x, or when x squared minus 4. So we're going to graph our parent function. And remember, this is something that you're going to want to kind of memorize what this looks like. And we're going to graph it, although try and do a little bit better job than I did there. So this is our function here. So this is our parent function, where we have f of x equals x squared. Now we want to graph this minus 4. So one of the things that we can do is, if we'd like, is we could do a table. So I've got, let's see, -2, -1, 0, 1, and 2. And so this is x, and this is g of x. So when x is 0, our g of x is -4. When this is 1, so that's 1 squared minus 4, that's 1 minus 4 is -3. So 2 squared, 4, so 2 squared is 4, minus 4 is 0. So same thing here. We're going to end up with this graph. So I've got 0, -4, 1, -3, 2, 0. So if I notice, it's the exact same shape, except it's now moved down 4 spots. So this is our g of x equals x squared minus 4. So it moved down this axis of symmetry 4 spots. So what do we know here? We know that both graphs open up and have the same line of symmetry, which is x equals 0. Now, what's different is the vertex. So the vertex of g of x is 0, -4, which is below f of x, which is 0, 0. Because g of x is a vertical translation of 4 units down the graph of f of x, our parent function. So what we've got here is a new vertex, same line of symmetry, same parabola shape. Let's take a look at example 2. So now we've got a +4, but we also have a coefficient here. So our original graph, our parent function, 1, 1, 2, 4, 4, 16. Remember, now I've got more than I need, but you really only need 5 points. So here's our parent function. Now I want to compare this next one. So same thing as I can do a table. So I've got x, and then g of x, so -2, -1, 0, 1, and 2. So if I've got 0 squared, so that's 4, 1 squared, that's 1 times 2, so that gives me 6. 2, so that's 2 squared is 4, times 2 is 8, plus 4 is 12. So I'll have the same here. So now I have 0, 4, 1, 6, 2, 12. And so this is g of x equals 2x squared plus 4. So I have a narrower shape. I also have a vertical shift up. So what do I know? Both open up with the same axis of symmetry, which is x equals 0. The graph g of x is narrower and its vertex is 0, 4, which is above f of x, which was 0, 0. Now, because we have an a here, that 2, we've got more going on as well. The graph of g of x is a vertical stretch by a factor of 2 and a vertical translation. That means translation means move 4 units up of the graph of f of x. Okay, so it is your turn. What I'd like for you to do now is hit pause and go ahead and solve 1 and 2. There will be some questions after this spot for you to answer in the video. All right, let's take a look at example 3 now. So describe the transformation from the graph of f to the graph of g, then graph f and g in the same coordinate plane. So first thing we're going to want to do is set up a chart. So we've got f of x. So from here to here, we're using our f of x, which in this case, this is the parent function that we're starting with. So we've got 0, 1, 2, -3, 4, -11. And because it is a parabola, I know what the other -4, -2 will be. Next, what I want to do is subtract 3 from those. So 1 minus 3, -2, -6, -14. Once again, I know that this is symmetrical. So I've got my points. Now let me go ahead and graph it. So this is going to be my first one. So I have 0, 1, 2, -3, 4, -11. So this is my parent function here. So that's f of x equals -75/100 x squared plus 1. And now I'm plotting my other one. So I have 0, -2, 2, -6, 4, -14. I got to be careful how I draw my parabola there. So this here is my g of x equals -3. So I should really have been more careful with my drawings. Make sure, because otherwise your graph isn't going to make much sense like mine didn't. So make sure you graph that correctly. So now describe the transformation. Well, what happened? The graph of g of x is a vertical translation 3 units down of the graph of f of x. So now let's write an equation. Well, I know that g of x is f of x minus 3. Well, what is f of x? That's negative 75 hundredths x squared plus 1. That's my f of x. And now I have my minus 3. So this right here is my f of x. So what is g of x? G of x is negative 75 hundredths x squared minus 2. Okay, so now it is your turn. Go ahead and hit pause and answer the questions on the screen. Be sure to show all of your work carefully. Okay, so for our last example here, let's take a look. So let's model a real world problem here. So a zero function f is the x value for which f of x is 0. A zero function is an x-intercept of the function of the graph. Well, what in the world does that mean? Well, let's take a look. So the function h of t equals negative 4 and 9/10 t squared plus s sub 0 represents the approximate height in meters of a falling object t seconds after it is dropped from initial height s of 0 in meters. A coin dropped from initial height of 44 and 1/10 meters. So how many seconds does the coin hit the ground? Well, we need to have our equation. So I know that s of t, or h of t, I'm sorry, negative 4 and 9/10 t squared plus the initial height, which is 44 and 1/10 meters. So what I'm going to do now is graph this on Desmos. So now I'm going to go ahead and graph this on Desmos. So I've got y equals negative 4 and 9/10, whoops, x squared plus 44.1. Now, the zero function is where does it hit 0? Does it make sense that it's going to hit at -3 feet or -3 seconds? Or where is it going to hit in 3 seconds? So here is our answer. So in how many seconds does the coin hit the ground? 3 seconds. So I know by graphing on Desmos, my answer is going to be about 3 seconds. Now, the other way I could have solved this is I know that my height here would be 0, and so I can then solve the equation if I would like. Now it says, suppose the initial height is m meters lower. How will this affect part A? Well, if I drop it from a lower height, will it take longer for the thing to hit the ground, or will the coin take less time? Well, if I drop it from a lower height, the coin would take less than 3 seconds to hit the ground because it's being dropped from a lower height. All right, you can go ahead and